All right, welcome back to the Explainer. Today is the day we take all those requirements we gathered and actually transform them into a production-ready, high-level design. We've already spent a ton of time digging into the business, nailing down our stakeholders, mapping out functional capabilities, and really locking in those strict non-functional constraints. So our objective right now, we're taking all that abstract planning and turning it into a concrete architectural blueprint for a massive hospital information system. Let's get into it.
So, after all that heavy lifting with the business and functional requirements, we finally hit the ultimate question that every architect eventually has to face. What should the solution actually look like? Honestly, it's a pretty daunting moment. Faced with this completely blank canvas, a lot of engineers kind of just panic. They immediately fire up their diagramming tools and start chaotically dragging and dropping boxes and arrows everywhere, totally losing sight of the core business.
But as we know, experienced architects don't just start drawing. They know the absolute best designs are deeply rooted in understanding the business first. There's this quote that hits the nail on the head. Architecture diagrams are the result of good requirements, not the starting point. Seriously, if you start drawing before you truly understand the business context, you're literally building a house without a foundation. It's going to collapse.
Okay, quick look at our roadmap for this explainer. We're going from requirements to reality, outlining core components and integrations, mapping the patient user journey, handling data, security, and scale, diving into cloud mapping and trade-offs, and wrapping up with some real-world consulting lessons.
Let's kick things off with Section 1, from requirements to reality. We need to look at how our foundational elements actually interlock. Our business requirements, those define the why, the big picture goals of the hospital. The functional requirements define the what the system literally needs to do every single day. And the non-functional requirements define how well the system needs to perform. The vital metrics like speed, availability, and security. These three pillars, they are now the driving force behind all our crucial architectural decisions. They're our North Star.
Now, the absolute key thing to remember about a high-level design, or HLD, is that it focuses purely on the big picture. We are intentionally leaving out the low-level weeds like database schemas for later. Think of the HLD as the architect's initial sketch of a house. It shows the rooms and how they connect, but it completely skips the plumbing inside the walls. It exists to align everyone, from the engineering teams to the operations staff, all the way up to the business execs. We need everyone nodding in agreement on the structure before we start pouring the concrete.
Moving right along to Section 2, Core Components and Integrations.
This is where we start organizing the chaos into distinct layers. Right at the top, we have our portals. These are the highly customized interfaces for the patients, doctors, nurses, and the admin staff. Just beneath that, we've got our core services. This is the true engine of the hospital, handling the heavy lifting, like patient management, appointments, the massive electronic medical record system, and of course, billing. And supporting all of that, our infrastructure layer, equipped with an API gateway, an authentication service, a caching layer, and message queues. I want to emphasize this. Every single one of these components is here for a very specific reason, driven by our requirements. We aren't just adding them for the fun of it.
And keep in mind, enterprise systems like this practically never operate in isolation. A hospital system has to talk to the outside world, and it has to do it fast. We need rock-solid, seamless connections with insurance providers and payment gateways because, well, we have to handle billing. We often have to report directly to government healthcare systems too. We're relying on external identity providers for secure logins, and we absolutely have to integrate with external systems like SMS notifications, lab equipment, and radiology PACS systems. Honestly, this sprawling web of integrations is exactly what makes enterprise architecture so incredibly fascinating.
Next up, Section 3, the patient user journey.
To really see this in action, let's just trace a simple patient appointment booking. So, first, the user's request hits the load balancer, which is basically acting as our traffic cop. Second, it gets forwarded over to the API gateway. Third, our authentication service steps in to validate the user, making sure they're exactly who they claim to be. Fourth, the dedicated appointment service processes the actual request. Fifth, the database securely stores that appointment. And finally, notification and logging services are running quietly in the background to capture the transaction and fire off that email confirmation. This step-by-step sequence is a brilliant example of how one simple user action triggers this beautifully seamless collaboration between a whole bunch of microservices.
All right, let's dive into Section 4, Data, Security, and Scale.
Listen, when it comes to data at this scale, a one-size-fits-all approach is an absolute recipe for disaster. Different workloads demand completely different storage strategies. So for our daily, rapid-fire operations, we use a transactional database. But for those highly sensitive electronic medical records, we keep those isolated in a dedicated, ultra-secure EMR database. Crucially, we use object storage specifically for heavy medical images, stuff like MRIs and X-rays. If you tried jailing those into a standard relational database, you'd probably crash the entire system. We're also throwing in a caching layer for lightning-fast data retrieval, an analytics database for reporting, and specialized logging storage for our audits.
Now, how are we protecting all that sensitive data? In architecture, security is all about creating strict boundaries. We apply zero trust principles here, which literally means we trust absolutely no one by default. We tightly control access at every single layer. We've got strict internet boundaries set up with web application firewalls. We keep our databases and internal APIs completely hidden away as private services. We're managing the whole show through secure management networks and locking down passwords with secrets management. By strictly enforcing identity and access management with least privilege, we ensure that even if one user goes rogue or one service gets compromised, they can't bring down the entire hospital network.
Of course, scale and reliability are just as critical. A hospital system simply cannot afford downtime. Zero. To guarantee that, we build across multiple availability zones for built-in redundancy. We're utilizing auto-scaling to instantly handle sudden spikes in traffic and database replication to prevent any nightmare data loss scenarios. And by using asynchronous messaging and stateless services, we achieve what's called fault isolation. That just means if, say, the notification service crashes, the appointment booking system keeps right on running without skipping a beat. All of these high-availability decisions are direct answers to those non-functional requirements we locked in earlier.
That brings us to Section 5. Cloud mapping and trade-offs.
So let's take a quick look at how our logical design translates into physical reality. Our generic Kubernetes containers, they map perfectly over to Google Kubernetes Engine. The relational database becomes Cloud SQL. Our object storage translates straight to cloud storage. The message queue naturally maps to PubSub, and caching becomes Memastar. It's a perfect illustration of our blueprint in action. But hey, keep in mind, you could build this exact same layout on AWS or Azure using their equivalent managed services. The logic doesn't change.
And that actually brings me to a massive mindset shift. The cloud provider is not the architecture. The architecture is the design. This is a huge takeaway for any enterprise architect out there. Your design holds true regardless of the vendor you end up choosing. You are the one designing the logic, the flow, and the boundaries. The cloud provider, that's just the hardware store where you go to buy your materials. Architecture really is just an endless series of tough trade-offs. Are you going to go with microservices or maybe a modular monolith? Are you leaning on managed services or going the self-managed route? Should you build synchronous APIs or rely on event-driven communication? Every single day, you are balancing performance against cost and complexity against simplicity. The best architects evaluate these trade-offs strictly based on the business requirements, not by chasing whatever flashy technology trend happens to be going viral on tech blogs this week.
Let's wrap things up with Section 6, Consulting Lessons and Takeaways. Out there in the real world, you'll see the exact same errors repeated in the trenches. You really have to watch out for the temptation to add unnecessary components just so you can slap some shiny new tech on your resume. Beware of over-engineering things, and whatever you do, please don't ignore your non-functional requirements. Try to avoid creating poor service boundaries where literally everything is bottlenecked by a single database. Mixing responsibilities or ignoring operational complexity will completely ruin an otherwise brilliant design, simply because your operations team won't actually be able to maintain the thing.
Okay, let's quickly summarize our journey. Always remember, business requirements drive the functional requirements. Those functional requirements define the system's actual day-to-day capabilities. The non-functional requirements shape the overall quality and reliability. And finally, our high-level design transforms all of that into one coherent architectural blueprint. The grand takeaway here is that every single component on your whiteboard exists for a very specific reason. Good architecture is always highly, highly intentional.
Now that we've got our blueprint locked in, it's time to get into the weeds. Coming up next in our Explainer series, we are tackling low-level design, or LLD. We are going to zoom way in on individual services, APIs, databases, authentication flows, and the nitty-gritty deployment specifics. Make sure you join us for that one, because we'll be transitioning from this high-level blueprint right down to the granular implementation details. We're literally going to figure out exactly how the tables in that database are structured. But before we wrap up today, I want to leave you with one final provocative question. Look at your own projects and ask yourself, are your architecture decisions truly driven by business objectives? Or are you just following the latest technology trends? Really think about that as you apply these lessons to your own designs. I can't wait to dive into the low-level design with you all next time.